So anyway, I'll start without that, see if it comes back. Oh, here, perfect. So here's a little bit of what we're going to be covering today. It's going to be a short introduction, and we're going to take a look at what's been going on in 2014 in Shadertoy, and then also we'll talk about the new features as well as give an introduction to the hackathon properly, and then our guest speaker will take over it, and then we'll come back and announce what the theme of the hackathon is. So, does anyone in the audience have never used Shadertoy? All right, perfect. So, Shadertoy is a website. We're using WebGL. We created a community of people who wants to share knowledge. Specifically, they want to share about shaders. They want to share how to create them, how to make them better. So we created this website, shadertoy.com. This is the main website, the main entry point. The bigger canvas is the shader of the week, which obviously keeps changing every week. And the shaders underneath it are kind of like recommended, featured shaders that we cherry pick from all the contributions. Shadertoy has currently more than 4,300 shaders or something publicly available. There is then way many more private and even more drafts. So yeah, it's a huge community. The interface, when you're editing, on the left side you can see the viewer, again running WebGL. On the right side you can see the code, which is usually GLSL, or it is always GLSL, and then we have a section for social interactions, which is on the below the viewer. The code, as you can see, as I was saying, GLSL, there's a tab as well where you can add sound, and Inigo will talk a little bit more about it in a bit. And below the code, you will see there's some inputs that we let people use. There's 4 inputs, and you can assign textures, sound, videos to help you create better shaders. And finally, the viewer, we expose some information, such as the number of views that this specific shader has had, the number of likes, the comments, and so forth. And finally, there's a section where there's a section where you can see interactions between the different people to trying to improve the shader, or just giving a cheers, or like, oh, no, this is really cool, blah blah blah. And we've seen really great interactions where people point at each other how to make the shader better or how to minimize it. So as I said before, we wanted to kind of like go through the best of 2014 in our opinion, and this is kind of what we've picked because of for different reasons. But this one was Shader of the Week not so long ago. It does modeling. It converts polys to distance fill. And speaking of, actually, on Thursday there is a session that specifically covers that topic. So if you're thinking about doing some creation that is trying to do modeling, please attend that session as well at 3 p.m. I believe. And so. Let's see. So this is, if you guys remember, back in the 90s, there was a game called Unreal that then became Unreal Engine, and then Epic got really rich. But so this is the whole intro of that game running on the browser, and in one shader. Again, the Shadertoy, you only have one function call, right? So you need to put everything in that function call. So I'll let you think about this.
And this is a very slow computer, by the way. That's why it's running very slow.
Yeah. If you don't trust it, you can come and see how big this is.
It's big but slow, yeah.
So Shadertoy is a community, and as a community, sometimes things go viral. In this case, this one got viral with more than 100,000 views. It probably was like a couple of weeks ago. We just start seeing spikes on the data that was getting us from the user views. And we were like, wait, what's going on? And then, you know, it was all over the place in Reddit and all that. So it's impressive. It's beautiful. Then, because it's a community, sometimes magic things happen. We put in a feature back in last year, maybe like middle of last year, where it would show the character counts. Basically, it would tell you how many characters have you used in your shader. And suddenly, Nimitz decided for himself that he wanted to do a competition. So he published a shader with only 2 tweets, so 280 characters, and it got picked up by the community, and we got more than almost 100 contributions, and in about 2 weeks. And so this is the winner of that competition. It's a shader written by Dave Hoskins, Mystery Mountains, and because we've changed the API. It's not anymore 280 characters. We'll cover why we changed the API, but it's really impressive.
So maybe we should say that the character count doesn't take spaces and comments into account. So you don't need to minimize or obfuscate your code by hand. The counter takes that.
It's this counter, anyway. This counter down here that if you actually click on it, you can see the minimal shader code as well that it generates. So.
Oh, okay. I'm going to take over from here. There is this other shader which we found pretty impressive. It is doing procedural modeling and animation. There is some analytic IK going on for the movement of the legs, and it's doing a smart use of the mod operator, which is a way to mathematically repeat a function forever by doing a mod. And that means that there is only one of those camels, lamels, deers, whatever they are. There is only one defined mathematically with a sphere and some cylinders, but then the ray marcher kind of makes sure to place one every tile of the world. So it's a pretty nice one. I don't know if you can move the camera. No, you can't. There is this one. It's a beautiful shader. It's called Tokyo. And not only it's beautiful, and it has some impressive modeling of cars and things like that, and some beautiful rain, but I guess the most different feature in this shader is that you can see there is some kind of glow or bloom effect on the light sources. And the way you normally do that is by doing multiple render passes, or render into a texture your lights, then you blur, then you add back to the original color buffer. But you cannot do any of those things in Shadertoy. There is no multipass. Everything you render it at once as a function of the pixel coordinates. So in order to do glow or blooming effects, you need to resort to other techniques. So this is one example of a clever use of the distance field representation of the scene and it's using that to gather light information as you ray march the scene, and that allows him to do glow without multipass. This was the year of anti-aliasing in Shadertoy. Last year it was the year of motion blur. This is the anti-aliasing. It means people did research on how to perform anti-aliasing in smart ways without multi-sampling. So of course, when you render your images with a ray marcher or a ray tracer, you have all these jagged edges, everything looks ugly, and one way to solve it is by casting many rays per pixel, but then it becomes very slow. But because most people are using distance fields to do modeling, and again, I think you should go maybe, I think it's next Thursday, it was 3 p.m. to the talk about modeling with distance fields. You will learn more about it. But basically, it gives you extra information about the scene, and then you can perform anti-aliasing basically for free, almost analytically. So in this case, we have these cylinders with beautiful soft edges. This is what it would look like without anti-aliasing. I don't know if in the projector anything can be seen, but here in the screen, I can really see a big difference. That's especially useful for rendering fractals, where basically by definition you are going to be aliasing all the time, because a fractal is something that has infinite detail that will never be captured by a pixel. So performing anti-aliasing, analytic anti-aliasing, it's very useful. So this is a beautiful example of using it for rendering fractals. And this is probably one of the most impressive shaders of this year. It was made by an old demo scener. You might remember his demos from the 2000s and 64K intros. And this is a shader which it should have some sound, by the way. I don't know if we can switch the sound on, just a little bit. Well, I will talk in the meanwhile. So this is a shader where, as you can see, you see a picture there of Terminator, but there is no textures in Shadertoy that provide you the picture of Terminator. So what he did is to take this base texture down here that we do provide, which is a generic pattern, and then by picking the right areas of that image in small tiles and rotating the tiles and placing them in different areas, he reconstructed the face of Terminator, which is pretty sick, right? It's kind of a new way of compressing images, perhaps, and that was pretty crazy. There is some sound on it. I don't know if we can play it now.
Yeah, we should reconfigure it. Do the setup again, because we unplug it.
Which setup? The sound?
Whatever you did before.
I don't know what I did. It's not making any sound, indeed. Should I stop? And enable?
Should we play again?
Okay, there we go. There is some sound, which is made here. Again, we don't provide any Terminator-themed MP3 file anywhere, right? So what this guy did is to write a small sound synthesizer in GLSL, which runs on the GPU. And we will explain now how this shader actually gets used by the sound card, right, to kind of translate all these computations into sounds. So actually that's one of the new features we added to Shadertoy, which provided a lot of fun and joy, which is indeed to create sound in the GPU. And this is done by using a shader which bakes the sound into a texture. So we have this 512 by 512 pixel texture, and it's an RGB8 texture, 8 bits per channel, so we are using the red and green channels, or color channels, to encode the left sound channel, and the blue and the alpha to encode 16 bits for the right sound channel. So what we are doing is running this shader in that 512 by 512 texture, bake the values there, read the texture back in the CPU, and create a web audio buffer, put it there, and send it to the sound card. 512 by 512 can only encode 6 seconds of sound, so we are running this in a loop, and basically, but we are pre-computing all this sound, so we are pre-computing 1 minute of sound. We did try to call the shader on the fly as the web audio was consuming the sound buffer, but there is a lot of latency, and we didn't manage to get it real time. There was a lot of glitches and sound imperfections, so we decided to do it pre-computed. It seems to be working fine for most people. And the catch here is that when you do a sound synthesizer, you normally apply regular synthesis techniques like filtering and reverbs and whatnot. And all those techniques are based on buffers, where you store the previous samples of the sound and then you process them to create new values. But you don't have that in Shadertoy. Basically, every sample of the sound, of the whole wave, every sample is computed in parallel on the GPU as a pixel in the pixel shader, and those samples don't know about the samples around them. They don't know anything about the past or the future, so they cannot do filtering. So that means that when you see a shader with sound shader that sounds like it has reverb or some nice filtered qualities, it's because they created a new way of filtering sound. And again, that's an example of the kind of creative things that happen in Shadertoy just by the limitations that we have. And this is one of the best sound shaders, I believe, also by again, another demo, the same demo scener. So let me play it. It's a 1 minute long mini demo. There we go. So somewhere here, between these lines, there is magic happening to make that tune. I don't know how he did it, but I guess this is encoding some patterns and notes and frequencies. I don't know. There's something there. So I thought we would quickly explain how this actually happens, and this is the risky part of the presentation where everything can crash, I can get nervous and not make it right, but we'll try. So let's see. This is our sound shader. When you create a new sound tab here, it comes with this default sound, just to kind of give you an idea of, it's a placeholder. Then you start replacing it. But this is the place where we output the sound wave. And you can see it's a vec2 instead of a float because we are allowing people to do stereo sound. And my hands are shaking. Anyways, so this is a sine wave. If I remove the exponential part of it, it's a continuous sine wave. If I add an exponential to it, it kind of makes this attenuation sound. Of course, I can tweak how long that sound lasts. Or I can do things like make sure that the sound is, the exponential is repeating itself all the time. There we go. Like every second, twice a second, 4 times a second, whatever. The font bigger? Yes. There we go. Sorry for the nagging sound. Let's change it quickly. So this number here is the frequency or the pitch. I can make it any frequency I want. And one technique that is used a lot in sound synthesis is to use phase modulation, which means you add a number there, and you actually make that number again a sine wave, or any wave you want. But if I add the same sine wave, I'm sorry for the typing, I can get different sounds. So this would be the regular sine wave. And as I increase that number here, this is called the index, the modulation index. I can create, let's call it I for index. I can change the quality of the sound. So let's put it to 20. But again, I can modulate that thing again. So we can add another sine wave. And then you start getting some more interesting sounds. Do I have time? Or we do? Yeah? Okay.
Go for it.
So let's play a bit more and do some other sounds, just to show that we can do more than just sine waves. Okay, shut up. So let's create some other sound. In this case, I can use a sine wave again of 100 hertz. Well, 100 by 2 pi divided by 2 pi hertz, whatever that is. And then I can change the frequency, not by adding a phase to it, but by exponentially decreasing it. And let's see what does, I don't know, 10. And maybe I can repeat this every twice a second. Okay, it's doing something. Let me multiply that by something big. Oops. Up. So that will be another sound. We can put both together. And we could maybe add another one of, I don't know. In this case, I'm just playing with numbers to get a different sound, probably. And I'm going to phase that by half a second and then add it again. Anyway, you get the idea. I'm not a musician. I cannot do the right thing. But by playing and playing, you can end up composing some simple music. It's not the way you would normally do music, but this is not the way you would do graphics anyway. Paul.
So, and then while looking at the database, we're like, oh, well, we have thousands of shaders, so we thought, well, maybe people out there want to do something with them that we cannot think of. And so we decided to create a public API. So basically, you can just, as a registered user, you can create as many apps as you want, and with that code, you can basically access the shaders on our database. Let's take just a quick look at this. It's very simple. What we've done, it's nothing too mind-blowing, but we allow people to query our database with any sort of a string, and then we basically, you pass the shader ID back to us, and we'll get you a JSON with the code, so you can use it on your own app. And it runs on our server, so it's all HTTPS and stuff like that. But also, the best way to test things is usually by doing it yourself before you actually allow other people to use it. So we build a Shadertoy client native app. So you can see it in the screenshot.
Yeah, this is a native C++ client running on Windows. And of course, because, as you guessed, if you have been to the GDC or this GTC, everything is about VR. If you don't have VR in your presentation, you are not allowed to talk. So we added VR. And we do have VR in the application. So we won't show it now here, but we will show it tomorrow. At what time is it? 11? Oh, it's written there. 11:30, apparently. Room LL21D. So we will be showing how the native app can consume the shaders from the Shadertoy database. It can do it live. If you modify them in Shadertoy, you can see the results immediately on VR. And how it actually works seamlessly. Like, a reason we changed the whole API, if you have been working on Shadertoy and your shader was broken for 1 or 2 days a month ago, that's because we changed all the entry points of the shader so that they can work both in 2D and VR transparently to you. So we will talk about that tomorrow.
And just a feature that we introduced yesterday or a couple of days ago is the ability for people to broadcast while they're coding, because we thought it would be cool to actually see how people are coding the same way you guys are looking at what Inigo was working on. We thought, what if people can actually just watch other people coding worldwide? So we created this website called Live inside of Shadertoy. Let's see if there's anyone. Nope, but there's 8 people watching. So let's actually, we can do a little bit of a mock-up demo. Do you want to sign in?
Yeah, let me try. Maybe you can talk, I can type.
Yeah, so basically Inigo will show you the, there we go, somebody's creating a shader. So seamlessly pop up that shader that some user was creating at that point. But let's take a look at what Inigo's doing. In the editor window, we've put up this little icon where you like little antenna that you can click, and after you click that button, everything is going through a WebSocket up to the cloud and then distributed through the viewers worldwide, and people can actually see while you're coding what Inigo is doing. So if Inigo modifies the shader, everybody would get that update, including the keystrokes and things like that. So and we want actually people to use it. If you want to submit for the hackathon, please use it, because we want to test it and want to see what are the limits of what we're building, and so it will be really useful for us. And I'm sure, like, if you put a tweet up in the cloud like, hey, I'm writing code, check it out over there, like it will attract people to see you working.
Oops, I broke it. Yeah, so before we give the theme of the hackathon, at the end of the presentation, we are going to have Otavio give a small mini presentation of some of the shaders that he did in Shadertoy. So as Paul said in the beginning, one of the beautiful things in Shadertoy is that you learn a lot from what other people are doing. And even if you think you know a lot about coding, you see how other people solve the same problems that you would solve in a different way, and they do it indeed in a different way as well. So it's always nice to see what these other programmers are doing. And Otavio is one of those who create very nice shaders, and we have him today here so he can explain to us how he solved some of those shaders. So come on stage and show us.
Is this on? Where's the on switch here? Okay, nice.
Oh, Ben, show me. It was somewhere.
Hello, hello.
No. Where did it go? Here. There.
Check, 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 check. Hello, hello. Okay, cool, cool. Okay, so just to start off, I'm not representing my employer's views. Okay, now I can say whatever I wanted. So I just figured I'd just go over some random tips and stuff that I use when making shaders in Shadertoy, and hopefully it's at the right level for at least some of you. I really didn't know exactly what level to put this at. Yeah, some of them. Yeah. Actually, I'm curious, like, how many people have implemented a ray marching algorithm before?
You see?
Oh, okay, yeah, good number.
I told you.
All right, well, this is kind of building off of that, I guess. Let's see. So, yeah, okay, so I see Shadertoy, and I see a lot of people doing a lot of really amazing math, but somehow their stuff, it seems like they're selling themselves short a little with the look, and I think a lot of that is because of the lighting. And so I just wanted to go over some lighting basics and go over the framework that I kind of start with when I'm starting a 3D shader and what's going on in the lighting. So I'm just going to break it down into components, break this thing that you see right here into all the components of the light. Well, what this shader is doing is, actually, let me tab over and just bring it up really quick.
You can hold the mic.
I got it. It's good.
Oh, okay, sorry.
Shadertoy/user/Otavio good. And this particular one, I guess, wasn't my most popular one, but it's a good demo thing. Oh. Yeah, so what this shader is doing is basically taking some noise and just scaling it up off of a sphere and trying to light it nicely and give it some nice texture and stuff. And so, yeah, I'm just going to go through the general...
Hold it.
No, I got it.
Yeah? Okay.
Okay, so start out, sunlight, ray marched shadows, nice hard shadows, and I think that a lot of people are kind of scared to, like, blow out their sunlight a little bit, but sometimes it looks good. Skylight, ambient occlusion. This is just the skylight component with the ambient occlusion. And for skylight, what I do is I'm trying to simulate a hemisphere light coming from all above. And so it's the cheapest approximation in the world, but I just kind of linearly interpolate based on the vertical component of the normal. So if the normal y is the vertical component, it's going -1 to 1. I take it 0 to 1, and I just interpolate the blue color to black down at the bottom. And then that can kind of be combined with the next step, which is the ground light. You know, a lot of light out there is bounced light, and if you don't have some good faking of bounced light, your stuff isn't going to look very realistic, I think. So this, once again, is just a linear interpolation based on the y component of the normal. Sun reflection, this one is pretty straightforward. I guess it's the standard, you know, reflection models combined with ray traced sun shadow. Fog is the trick to making anything look big. And then, so this is just all the lights combined together with the fog and no texture. And then this is lights, fog, texture. So this is basically the whole thing. And then another thing is the gamma correction. I see, I mean, a lot of people leave out gamma correction. And gamma correction, I think of it like it's a way to compress textures. Like textures basically want to have values that are going 0 to 1,000 or something, but you only have 0 to 255 to play with. And so anytime you pull something out of a texture, you got to gamma correct it to get it to those kind of, to that bigger range. And then anytime you write anything out of the shader, I just generally square root the stuff. I've seen other people do more precise gamma correction, but it's good to start from a properly gamma corrected thing, because that's kind of what physically correct light would be doing. And then if you like the style to be a little bit different, then you can tweak on it from there. So this one is a little trick that I use sometimes for getting textures. When I make a distance field, sometimes I'm clumsy and I don't scale the distance field properly. So sometimes that ends up making for a really nice looking texture. And if you're just sitting there and you got some noise function and you're like, I need some texture for my objects, check the distance field and look at the length of the normal that you get from the distance field. So generally when you get a normal from a distance field, you look at the gradient of the distance field. And if you look at the magnitude of that gradient, that's what's being visualized right here. Ideally, the magnitude of that gradient would be the same everywhere, because it's supposed to be a distance field. It's supposed to tell you how far you are from a surface. And if that's wrong, you're going to have to put a multiplier on your ray marcher, and it's going to slow down the frame rate and stuff like that. But hey, sometimes I'm clumsy with this, and it's wrong, but it looks cool. And so it's a fun little trick to just use the length of the distance field gradient as a texture map. This is just a screenshot from another shader that I made where I actually took care to get the distance fields correct. I still didn't get them completely correct. Anything that's white here, kind of the brighter whites that are in the corners, like this stuff, is actually just an error that didn't look bad enough that I felt like correcting it. And then it looks like I've got some gray spots here that are a little off gray. But if you can get your distance field correct, it's something that you should really pay attention to, just visualizing the gradient of the distance field, the magnitude of that gradient. And if you can get that correct, then your frame rate is going to be a lot higher, because you're going to have a very efficient ray marcher. And I guess just to explain it one other way is, let's say you put like a circle and a square in your scene, and you want to make the circle bigger. You just multiply that circle by 2 or something, or multiply it by 0.5 or something. All of a sudden, you have one thing defining the distance field that's a factor of 2 off from the other thing, and that's basically going to make your ray marcher perform poorly or bug out. So yeah, it's just something to visualize and check and make sure you got it right. This is the full shader from that one. I guess I'll just switch over to that really quick. Let's see if it'll go full screen, because I said I had a good frame rate. Yeah, so this is the full shader. It's kind of a weird space station Rubik's Cube something or other. But, this uses the same lighting framework that I just went over from the other one. Even though it looks like it's in space, I probably threw in a ground light. I probably threw in a sky light, trying to simulate the hemisphere lights. I've got this hard sun with a hard sun shadow, stuff like that. And okay, another thing that bugs me a little bit is the highlights. There's some textures in Shadertoy, and they are not really high dynamic range. And so you bring it in and you use it as a reflection map. And when you use it as a reflection map, you usually multiply it by a smaller number, because it's probably not a total mirror surface. And so what happens is that the highlights that are supposed to be like the sun or the sky or something like that, they go down to gray, and that doesn't look very realistic. And so pay attention to your highlights and make sure that it's as bright as it should be. So what I did for this environment map is I took the original texture, I did a POW to give it like a nonlinear ramp to enhance the highlights, and I added it back into the original texture to kind of simulate a high dynamic range texture, so that the sky would look actually really kick-ass bright, where the rest of the stuff in the reflection is kind of dim. You don't really see it. Okay, so now I'll go over this shader and just look at what kind of lighting I did in this. And I think you saw this at the beginning really quick, a little bit of it. So this shader, I don't know if it runs fast enough to be full screen, but I tried to do a lot of different lighting here and do bounced light and try to bring in different lighting components over time and stuff like that. Let me pause it. Go back here. Okay, so I'm just going to break down the components of this light once again. So this one I tried, there isn't a whole lot of direct light coming in because there's that one hole in the ceiling. So I tried to do a lot of indirect light. This is what I did to simulate the indirect light. It looks like it's just kind of like a basic distance from the point where the sun hits. And so it's a bit of a hack. The stained glass light, that's from the dome at the top has the stained glass thing that looks purple. So this also has ambient occlusion in it. In the case of this shader, I went way over the, I guess, WebGL budget for how much code you're allowed to have, so I had to keep cutting things back. The ambient occlusion, I couldn't really do a proper full ray trace of that, so I just did 2 little ray traces, and then I kind of hacked in. There's like a shadow underneath that ledge. That's all like hard-coded. I just kind of hacked in some of the ambient occlusion so it would look nice because I was running out of code space. Skylight, I don't know where the sky is in this scene, but it seemed to look good, so I left it in. So this is the skylighting component. The direct light, you can see it's just a little puddle on the ground, and it's probably already blown out because of the indirect light fakery. Fog always makes it look good. God ray, the God ray is just basically ray tracing a cylinder and throwing some noise inside it. That's a technical term, right? God ray? Yeah. So then this is all the lights with the normal map but without the texture. And so for the normal map, I just kind of took the texture map and perturbed the Y value of the normal. It's kind of a hack, but most of the light is vertical, and so it worked pretty well. Ray march count for glow. So if you're doing a ray marcher, the number of times you ray march will essentially tell you how close you are to a surface. And so if you just turn that kind of integer count into a glow, you'll get a nice glow really close to any surfaces. And you can do variants of that, like you can multiply it by some density value as you move along, by multiply it kind of by the distance that you've moved and a density value or something if you want nicer fog. In this case, I think I did it specifically only based on a distance from certain objects, so only certain objects would glow. And that's more ray march counting there. And then, you see all these runes all around the top of this thing, and even on that pedestal in the middle. The runes are, since we don't get our own textures to play with, the runes are all procedural. And what was done for this is for every rectangle, basically choosing a few points along the left side and along the right side, and just kind of randomly drawing 3 or 4 lines between them. And that's what seemed to look most like runes to me. And then these lines, they have gradients, kind of a gradient fall off so that you can do actual lighting with it, and it looks embossed and everything. And then at the end of the shader, maybe I'll just play this one through. So yeah, it goes through a couple different animations, and at the end I show this thing that says Solstice. And what that was is it's the random runes, and I manually selected a random seed for every damn rune, so I could find something that looked like it said SOL, whatever, Solstice, It's kind of ridiculous, but I had to make a random function that worked the same on everybody's computer. So what I did is I basically just did kind of like an integer texture lookup to find random values. And so yeah, this is the part right here. So that thing right there, you can see the random seeds down at the bottom, and I just kept searching for random seeds until I found enough that it looked right. And it's good that I didn't have an M or a W in the name of the shader because my random generator would have never made an M or a W. Yeah, just another little trick. I guess he was saying this is already like a year or two ago cool, and so it's probably not cool anymore, but stochastic motion blur and depth of field. If you just want to add a little bit of randomness to the ray vectors, you can get a lot of different effects out of that. And it might not look so good for a still scene because it is grainy like that, but if you're moving quickly, you won't notice it. And I think it's a really good way of taking care of near clip plane kind of issues, because if that looks awkward, I think I showed you my spherical fractal flying around space a second ago, and that one had a lot of near clip plane issues when it went in and out, and so I threw a stochastic depth of field on that one, and it looked pretty good. So yeah, I just figured I'd go over some things like that, and if anybody wants to nerd out about this stuff later, let me know. I'd be super into it. That's my username on Shadertoy. All my code is Creative Commons 0 because we're programmers, not lawyers, and I'd like to try to encourage everybody to do Creative Commons 0 so that I don't have to go all give an attribution and it becomes a legal issue all of a sudden. People generally attribute my stuff when they use it, so if you use Creative Commons 0, that doesn't mean you won't get attribution. It just means it's not a legal requirement. So yeah, let's talk about this stuff later, and I think it'll all be fun.
Thanks a lot, Otavio.
Alrighty, so let's create some shaders. So Hackathon starts as of now until Friday noon. Friday noon, we will collect all the shaders that were submitted and evaluate which ones are the best. The way for us to know that your shader wants to be in the competition is that your tag, either the name, you put a square bracket, NV15 square bracket in the name of the shader, or you tag, or you add a tag to the shader with that same string in it. And that way we will know your shader is applying to the competition. And we will have 3 prizes provided by our friends in NVIDIA. I do believe the first one of the prizes will be the best by far.
Yeah.
The other 2 will be awesome as well. The other 2 prizes,
but
the first one will be awesome. Huh?
The car, right?
The car, sure.
The car, yeah.
I'm going to start competing myself now. And yeah, we are going to give the theme about in a few seconds. Before that, if you could broadcast your live coding as you are coding your stuff, you can hit that broadcast button. It will help us test the system, and also maybe you gain followers. I don't know. It's going to be a fun thing to see how everyone is coding. Potentially, we will be playing it on the big screen here during NVScene in some selected moments. So at some point, you can see, we will be able to see all the participants coding. If there is anyone, we'll see how many we get. And this is the URL for the event, so you have more information there. We will be around in the NVScene all the time, so if you find us and you have any question, just stop us and ask anything you want. And we will announce the hackathon as well online on Twitter, so other people from the outside world will be also having fun with us. So the theme of your shader to be finalized by Friday noon is, where do we get it? The theme is space. Whatever that means to you. Like the universe, space, the space bar, space invaders, whatever it is for you. So that's the theme. And I think that's all we got for today.
That's it for today, yeah.
Yeah.
Thanks.
Thank you for NVScene, for having us here.